Hi guys, it's Miss Agini. I'm not there today. So hopefully you clicked on the link and you're watching the video. So with videos, the great thing about it is that you can pause it, rewind it, fast forward as needed. So if you need to skip some steps, you can do that as well. So for the agenda today, we're basically going to get our hypotheses and our methodologies done. So that'll be under benchmark 4. I'm going to show you really quick how to use Tinkercad for your 3D model, and then you guys organize your time and figure out how you want to work on this stuff for today. You need to have APA citations throughout your entire hypothesis and methodologies. Benchmark 4 is due tomorrow at 11 p.m. You're going to do it together as a group, and only one person per group needs to turn it in. You also have a test next class. You have an individual assessment of knowledge and thinking. So there's a review under G, assessment and evaluation. I'll show you how to get to that in a sec. So if you go to Echo, you're going to click on If You Build It, They Will Come. You're going to go to E2, Scaffolding and Support for Forming the Experiment. And then you should see Benchmark 4, Tower Design and Hypothesis. So if you look at the date, it's due tomorrow, the 23rd at 11 p.m. So it says, draw a 3D picture on Tinkercad to represent the tower to be investigated and provide an explanation of the representation. And I'll show you guys how to use Tinkercad in just a second. So you're going to create a 3D model, formulate a specific testable and challenging hypothesis, and explain the experimental process for your tower design with accurate and specific explanation of the relationship between your variables. So you're going to use the if, then, because thing that they taught you in middle school. So it says read the rubric for introduction to methodologies. So I tried to include everything that was in the rubric already. So for your hypothesis, and you also have to remember that you need to cite everything in APA format. And if you don't remember how to do APA, I'm going to show you an example. And then there's also citation resources under C. If you don't remember how to cite in APA, there's a video of me doing it as well under C, citation resources. So the first thing you need to do for your hypothesis portion is you need to ask yourself a question. So your question is basically going to be based off of your tower design. So some of us are doing pyramids, some of us are doing triangular prisms. It just depends. So if you're doing something like a triangular prism, your question might be, how do triangles affect the stability of a tower, or affect the height and stability of a tower? That might be your question. And it just depends on your shape. You have to come up with your hypothesis, and it says you have to clearly explain your hypothesis and give details as to why it'll work. And I give you guys sentence stems that are really, really useful. So this is how you should, start your hypotheses off. So a good way to start off is our tower will be the tallest because the design is in the shape of whatever your shape is. This design will work to our advantage because whatever research you guys did. And then what we know about our experiment before we start is, and then your background information, which you guys actually assigned each other last week, and you got most of that information off the entry doc. And it also needs to be cited, even if it's on the entry doc, and I'll show you how to do that in a second. So you should have a lot of this stuff. An example of another sentence stem that I gave you is, this study was done because, and then you fill out the rest. So this stuff, the question, and all this kind of goes with number 1 for your hypothesis. So after you answer this, read it, and then ask yourself, are the objectives or the purpose of the study evident? So ask yourself, was there enough information to frame the study? If not, add some more background info to this part, the tower design. And again, most of this stuff you can get off of the entry doc. So all these 5 things should be included in your hypothesis. The second one, after your background information and some of your research, in addition to describing how your tower is going to look, you need to give me scientific evidence to explain why your tower design is structurally sound and stable, and what supportive structures you're using. And you need to explain to me what would happen if your design lacked these elements of stability and why. So most of you guys use the forces lab with the different shapes and the rectangles and the triangles under section D. So that's something that you can cite for number 2. Use of supportive materials. So I should see in your literature cited the entry doc, some websites that we used on D, and the online textbook or the PowerPoint if you're explaining what some of these variables are. Somebody needs to answer what the null hypothesis is, and then you need to ask yourself whether or not your research question is testable. For methodologies, is there enough information provided to replicate the experiment precisely? So just by reading your methodologies, I should be able to do exactly what you're going to do on Monday, just by reading it. So did you give me, specific lengths? We're going to cut spaghetti 10 centimeters tall each time, add a marshmallow at both ends, repeat this 5 times. You need to have specifics on your experimental design. Are all the materials used listed? So if you're going to cut the spaghetti, it's not just spaghetti and marshmallows. You need to tell me what you're going to cut it with. Are you going to be using rulers? That kind of stuff. Include details on how you set up for collecting, organizing your data. Are you going to make charts, tables? What are you going to compare your height to? Are you going to take the height of all the other towers and then compare it to your height? Are you going to count the number of supportive structures in your tower as opposed to like the box tower? How are you going to organize your data? Include details on the experimental design, so that's your treatments, your controls, your dependent variables. Treatments, some of my other classes were a little bit confused with. This is actually your independent variable. Treatments and your independent variable are the same thing. So it's the variable that's intentionally changed by the experimenter to see if there's a difference in the dependent variable. And most of that stuff is in your notes. And it's on the PowerPoint under the first E. So this is a good way to kind of set this paragraph up. So the independent variable in this experiment is, and then you have to tell me because, and then the reason behind it. So if you just tell me, that your control is the box tower, you're only answering half of the question. So you need to tell me, the control for this experiment is the box tower, because, and then the definition of a control. That's also citable. So most of you guys will get the definition of a control from your notes. And if you need something to cite, if you go to E, scaffolding support and activities, the first one, it's a scientific method PowerPoint. And this is what you need to cite for that. But let me go back to E2. Okay, the next thing is include how your data was analyzed, which also kind of goes along with collecting and organizing data. So if you're going to compare, different structures, are you going to count the number of whatever? So in addition to this, so step-by-step instructions, geographic locations, and directions if you're conducting a field study. So for the geographic location of this experiment, it's actually going to be at school. So you can use Google Maps or whatever and get coordinates, and that's also something that's citable. You need to give me a summary of where the study was performed and include variables that might have affected your results. So the study again is going to be performed at school. So the summary could be, we're going to be in Miss Agini's lab. Some variables that you might include are, are the tables completely flat? Are some of them kind of leaning? Is the air conditioner blowing super hard all the time? Is that something that can, skew my results or topple my tower? Those are things that you need to give me for that. The easiest way to get this done, guys, is to copy paste this onto a Google Doc and then share it with everybody in your group and then assign everybody, questions. Somebody else also has to, somebody has to build the model as well. So if you're building the model, you might want to have a few less questions than everybody else. Everybody needs APA citations throughout the methodologies and hypotheses. And I'll give you an example really quick because I had some questions on those. So some kids were asking me, Miss Aginia, how do we cite the entry doc? Let me get a new blank page. And if you go to, let's see citation resources, if you don't remember, there's how to cite APA, and then you can download that. Sorry, you can probably hear my dog in the background. He's going crazy. The main thing we're going to use is websites. So for general web pages, you always need the author of the web page, the year it was posted or updated, the title of the web page, and then the URL. So I'm going to copy paste this just to remind myself onto a new blank document. So this is what I need for web pages. I need the author, the year was posted, all that stuff. I'm going to X out of this. Okay, so I'm going to look at the project launch and entry event, because that's where I'm going to get the majority of my background info from. Sorry, it's going crazy. Okay, so the title is Carl for a Field Biologist, but you always start off with the author, and the author's at the bottom, and it was actually me. So I'm going to write the author. So the author was A. Agenia. Then you need a comma. The year was 2016, because we did it this year. Now the next thing we need is the title of the web page. The title is at the very top. It's Call for Field Biologists. So I'm going to write that down. Call for Field Biologists. Titles are always underlined, and they're always italicized because it's a title. So Control U for underlining, Control I, oops, messed that up. Control I for italices. And then the last thing I'm missing is the full URL. So the full URL you actually get from here, and I just copy it and paste it. So this is how it's going to look on my literature cited. And it needs to be numbered. So whenever I use something from the entry doc, I have to put an in-text citation. So that's what the literature cited at the bottom of your research is going to look like. But I need an in-text citation wherever I use an idea from the entry doc. So let's say I got an idea. So I'm going to write a sentence. So monkeys are cool is a sentence that I'm going to write that I got from the entry doc. For your in-text citation, you need the author and the year. So oops, sorry guys, I keep messing this up. Agenia, comma, 2016, close parentheses, period. Okay. So this is how your in-text citations should look, and this is how your literature cited should look. So I should see in-text citations and a literature cited throughout your entire methodologies and hypothesis. Okay, so everybody's working together for this assignment, but I do need to know who did what, because you guys, even though you're doing the same assignment, you're all going to receive a different grade. So if you did numbers 1 and 2, make sure you write your name next to numbers 1 and 2. First name, last name, please. And divide it up that way. You also have a test next class. So if you go under G, Assessment and Evaluation, there's a review for the IACT. So for regular biology, I do offer extra credit for this. So it says download and fill out or print, or you can complete this on a separate sheet of paper, and I add 5 points to your test. So what the test is basically going to be on is the 3 things that we've covered. So it's going to be on variables, controls, dependent, independent variables, all the steps of the scientific method. So basically I'm going to give you examples of experiments, and you have to identify each of those components. The difference between qualitative and quantitative, importance of trials. And then you have to be able to convert between standard and scientific notation and inferences and observation. Those are basically all the need to knows that we've covered so far, and that's what you're going to be tested on. Okay, the last thing I'm going to show you guys how to do is start your model on Tinkercad. So open up a new tab, and then you're going to search for Tinkercad. And it's going to take you to Tinkercad. I need you guys to create an account. I'm going to go ahead and log out of mine so I can show you how to do this. So when you go to Tinkercad, you're going to see this. You're going to go up here to the top right hand corner and click sign up. You have to put in your birthday. So let's say my birthday was January 3rd, 2000, whatever. Click next. We're here is to sign up with Facebook. You're going to click more providers because it won't let you sign up through Facebook because our Ethernet blocks it. And you're going to click sign up with Google. and then click allow. I already have a Tinkercad account, so I'm going to go ahead and just log into mine. The first time that you sign in, you're probably going to see like a workspace and then like a weird screwdriver looking thing and like a circle. To get out of that, what you need to do is you need to click over here on the top left hand corner where it says Tinkercad, and it'll take you to what I'm currently viewing, which is like a robot, and then it says my recent designs. What you need to do is you need to click on create new design. So it'll take you to the work plane. You can change the eye level. So if I want it more eye level, I'm going to click the down button up here. If I want to see it from a top view, I'll click the top button, and then you can rotate it around 360, which is really neat. There's different work planes, which I never mess with. There's geometric shapes. You can cut holes. There's letters and numbers. The main thing we're going to use today is the geometric shape, so you're going to click on this cube right here. We're only going to end up using one shape today. I'm going to click on the cylinder shape. So what I'm going to do is I'm going to drag it over to my work plane. And there it is. I'm going to change the color up here. I'm going to change it to white so that it kind of looks like a marshmallow. And there's my marshmallow. I also need spaghetti, and I'm going to go back here and click on the cylinder shape again and drag it over to my work plane. I need to adjust it so that it looks like spaghetti. All these different buttons do different things. This little top one will help you move it up and down, but it won't change the size. So you need the one on top. So I want to make this taller like spaghetti, so I'm going to pull it up. Spaghetti is also really, really thin, so there's a square down here. So I'm going to grab one of the corners of the square, and I'm going to drag it in until it's like a 1 by 1. So you see the numbers on the bottom. Here's a 1 by 2, 1 by 1. And there it is. And if I rotate it, it looks like spaghetti all the way around. And I'm going to change the color to yellow so that it looks like spaghetti. Then what I'm going to do is I'm going to grab this piece of spaghetti and I'm going to put it in the middle of my marshmallow. Like that. And there it is, in the middle. So the hard part about this is getting it level and getting it to do what you want it to do. But once you build a few pieces, it's a lot easier. The shift button on Tinkercad is your buddy. That's going to be your biggest friend. So what I like to do is I like to build one or two things and then just copy it over and over again. Number one, because I want it to be the same size. So the way you do that is you're going to push the shift button down and you're going to click on the marshmallow. You're also going to click on the spaghetti and make sure that they're both blue. There we go. So now they're both blue. And it's just like Google Docs. If you push Control C, it's going to copy it. And then I'm going to click away from it and I'm going to click Control V and paste it. So now I have the same exact size marshmallow and the same exact size spaghetti, and I can continue building my tower. Remember, your model needs to have between 30 and 35 marshmallows, because that's how many you're actually going to have on Monday. So on Monday, you're going to take your test, and then after your test, you'll have 30 minutes to build your tower. And that's it. It needs to be able to support its own weight. Remember, we all have a control. We have the same control, which is this box tower. So once you're done with your design, it'll look something like this, and you'll be able to rotate it 3D and all that stuff. You need to include your 3D model in with your hypotheses and methodologies. So the way you do that is once you're done with your model, I kind of rotate it to where it's really easy for me to see all the marshmallows, and I kind of like it, you know. There's a good place to kind of settle. All right, you can take multiple pictures of your model if that makes it easier. So I'm going to take a picture of my model. And the way you do that is you all have, let me change my view really. Sorry guys, on the bottom left hand corner of all your computers you have these 4 little squares right here. You're going to click on your squares, and then you guys have a search bar down here at the bottom somewhere. My search bar is actually up here. So click on your search bar and I want you to type in snip, and then the snipping tool should come out. So the snipping tool will come out in the top left hand corner. You're going to go to new rectangular snip, and this is also how you rip anything off the internet, like pictures or whatever. So what you're going to do is you're going to select whatever it is you want to take a picture of. So I'm going to select my model. There it is. There's the picture. I'm going to go to File, Save As, and then save the picture onto my computer somewhere. So this is how you have the picture of your design in your hypothesis. Okay guys, so that's it. Hopefully this video helped. This is due tomorrow at 11 p.m. So I need all 15 questions done. Make sure your name is next to your question and a picture of your 3D model. Come in to tutoring or send me an email if you have any questions.